with the smaller particles of the sugar weathered first. Why do you think that those weathered more first are weathered more quickly than the larger particles?
They have less surface area.
They have less
See,
surface
that's
area.
less surface area.
Okay. All right.
Individual.
Yes.
Wait, what?
The faster it does,
So
the more surface
trying to.
area.
Never mind.
Okay. Somebody want to make any other additions to the observations? Okay. Melissa?
I was just gonna say that we noticed that the dissolved particles, it like the dust almost that was formed, almost dissolved instantly, and now it's just the same amount's been sitting there for a long time. Whereas this one was more at a more steady rate.
Which one
Sorry.
is this one?
This one being the whole sugar cube.
Okay.
At first started to dissolve fairly quickly, but then it slowed down and it's taking a lot longer for the whole cube to actually completely dissolve.
Why do you think that? What was the difference between the two?
It was more compact.
It was more
Sorry,
compact.
the whole sugar cube was more solid,
Okay.
so it had to wear away more layers, whereas the broken up, the weathered sugar cube was already in pieces, so there was more surface area on most of the parts.
Okay. So when you melt cheese in a pan of cone, right? Which one would melt more quickly? A hunk of cheese or grated cheese?
I know.
Why would the grated cheese, Brianna, work?
Because it's already been broken up to smaller pieces.
It's been broken up into smaller pieces, okay?
More of the cheese is exposed to heat.
Yes.
More of the cheese is exposed to the heat, exactly. Yeah, so when you broke up that sugar cube into tiny pieces, you were crumbling up, not just breaking that cube up into its individual sugar pieces, but those pieces were rubbing against each other and you were changing the shape of the individual sugar pieces. And so when you broke it up, there was more exposure, more surface area exposed to the water than that giant sugar cube. Yes, ma'am.
You also noticed that the sugar cube was releasing air bubbles.
Really? The sugar cube had some air bubbles trapped in there? Oh, that's interesting. Good observation.
How would you, not really related, it could be a teacher question before I get jumped onto this. The word surface area that we're using in this lesson versus the surface area in the math lesson? It's not the same, technically.
How do you
So, well, because I'm looking at surface area versus the piece, the ice, or not the ice cube, the sugar cube versus the water, instead of the surface area of the actual object, I guess you could say.
But could you not find the surface area of that cube sugar?
That's a cube, but the granules, the little the weathered part.
In the
Right.
microscope, you could measure those.
You could with your smart scope find the
Technically, you can measure the granules just as you could measure the surface area of the granules. Because it's basically just a smaller piece of sugar.
But would you still explain it as the same
Yeah.
formulation, I guess you can say, as?
Well, I don't know that there's a formula to come up with the surface area of each of those granules, like a consistent formula.
Yeah,
But it's still
like
a
how it was for
surface area.
density.
It's the area of the
It's
entire
still-
surface.
Yes. It's the external exposed part of
That we started with.
Yes.
Okay.
Yes,
I would say kind of like related to like that,
A surface area.
the way,
okay, y'all listen. Craig has an explanation for you.
I would say related back to that big 1,000-block cube, and if you broke up that 1,000-block cube in all the little different one units.
That's a great analogy. Thank you. That's good. Okay, so the process of dissolving the whole sugar cube to that of the crushed sugar cube. Compare the process of dissolving the whole sugar cube to that of the crushed sugar cube. Tanya, how did they weather differently?
it's kind of a.
Is that, did we feel like we covered that in that last question?
Yeah.
Because we did go into much of that. Okay.
Okay, another one.
Okay, how about this?
Make it easy.
What is the relationship between the exposed surface area and the rate of weathering?
For both?
Well, you compared two forms of sugar and the weathering rate. What's the relationship of this exposed surface area to the rate of weathering?
The more area exposed, the faster the weathering happens.
Okay, because, and relate that to what you observed.
Because when we poured the granules in, they were all, like Craig had brought up the blocks, they were all the ones. Whereas when we poured the sugar cube in, it was 1,000. So, you know, only the outer edges were being affected in the beginning, and it had to work itself in. Whereas all of those little ones, they were all being worked on at the same time in the same manner that the 1,000 was.
Great. And Craig, thank you for bringing up that cube. That's awesome. That was a great comparison. Thank you, Tanya. So does anybody have any results to share yet with your dissolving sugar cubes? Do we have complete dissolution anywhere? Okay. Keep timing this. But let's look at your weathering. Let's look at your weathering concept map. In your handout, there's a concept map for weathering that looks like this. Okay, weathering is a response to a changing environment. If the environment is not changing, if it's static, if nothing's happening, nothing is going to change. So it's a response to a changing environment. It depends on, the rate of weathering depends on the mineral composition of the rock, the particle size, and the climatic factors like temperature and moisture. There are two types of weathering. There's mechanical weathering and chemical weathering. First, let's look at mechanical weathering. Mechanical weathering is the physical breakdown of rock, which increases the surface area, and this rock is broken down into smaller pieces, increasing the surface area.
So why, when you shake or stir the water, does it dissolve faster? Because the particles are still all exposed to the water, but why does that make it faster?
Let's ask Melissa, she has her hand up.
I'm not, I'm just gonna take a lot of guess. Because I drink a lot of sugar in my tea. And right now, the sugar is resting at the bottom, so they're resting maybe on top of each other, so they're not exposed to as much water. When you mix it, you're exposing all parts of those particles. So then you're increasing the surface area. That makes sense, thank you.
And you're mixing that dissolved sugar up into the rest of it, so more can be released. Yes, Tanya?
You can also go into the energy. Now, I'm speaking 5th grade, so all you higher levels don't. So when you stir it, you're creating energy, which is it heating it up as you're stirring? Just like heating it? Is it not heating it enough?
It's exposing the water to air, so I guess it's pretty.
That's stretching it?
Hey, Dr. West is raising her hand.
Energy created.
No.
It Could you restate that, Tanya?
Energy is not created.
To go on the lesson because someone took too long. I don't know how to restate it.
Okay, what was the original statement? If you're like me, you don't remember it.
When you stir.
You said when
You're
you
stirring.
stirred it, energy not created. but-
You're moving the particles, which is
What would energy be doing then?
feeding up the energy.
Think about like the battery and
It
then
was
electricity.
wrong.
The
right?
battery and the light bulb.
Battery and then
What's
the
happening?
electricity. What kind of energy is a battery?
Electrical? Is that what you're asking me? We don't even get into chemical.
Well, what happens when you go from one energy to another energy?
One energy form
To another energy form.
I don't understand what you're asking.
When you're changing forms of energy, you call it an energy.
Transfer?
transformation.
Okay.
One form to another, transformation. So energy is transformed from some form to another form, electrical to light, or electrical to heat, or heat to, I don't know, what else. But precision of language is critical. So when we say things like energy is created, yada, yada, we perpetuate that myth with our children. And they're, then we tell them, no, energy is not created, it is generated.
So I will remember that for the rest of my life. Thank you all.
Okay, guys, let's go back to mechanical weathering here. So mechanical weathering, such as unloading, that's the example we saw at Enchanted Rock. It occurs in igneous rocks. It results in exfoliation domes, like Enchanted Rock, that's what it is. And it's a response to the reduction in pressure from erosion or the removal of the overlying rock down here at the bottom. You might make a note down here that an example is Enchanted Rock. Whenever all of this everything over the rock is exposed, that pressure is removed. It's not sitting on it. So it's more free to fracture and crack. Another form of mechanical weathering is frost wedging. This is the expansion of freezing water that results in cracks and crevices in the rocks. We have another form is from biological activity. This is organisms like plants, animals, and humans with our bulldozers and rock hammers. And then we have thermal weathering. This is the repeated freezing and thawing that makes cracks in the rocks. One thing that is not on here that I feel like it should be is just abrasion of rock against rock.
I have a question.
Yes, ma'am.
About frost wedging and thermal weathering, and you talk about freezing and freezing and thawing of water
Yes.
creates the cracks in the rocks.
Uh-huh.
Why is that not also considered chemical? Because it is water that's actually getting in between the rocks.
It is, and you're right. However, it's not interacting with the rocks. It's not changing the rocks except to push it apart.
What if it's
This-
limestone?
Pardon?
What if the rock is limestone?
What if the rock is limestone?
So the water flows into a crack, and it's like using a pry bar to
Right.
pull it apart. It's the physical expansion of the water.
But to me, in my mind, I'm thinking it's still water,
Yeah,
And because it's water, it's still partially chemical.
right. And there probably is some sort of weathering that goes on in there between the water and the rock. But this wedging apart is the actual mechanical part.
Okay.
We're isolating it to just the expansion of the water.
Okay.
Okay, the other type of weathering is chemical weathering. It's caused by water with dissolved oxygen that oxidizes material, or water with dissolved carbon dioxide, which forms carbonic acid. So when any rain falls, it's going to have gases that it absorbs from the atmosphere that will result in dissolved oxygen or dissolved carbon dioxide that yields the chemical weathering. Chemical weathering involves complex processes that alter the mineral structure by removing or adding elements to form new compounds. Chemical weathering transforms rocks into new compounds. So maybe that's the answer to our question with the confusion of just water, is that it's never just water. That water came through the atmosphere and it always has something else in it that causes those chemical reactions. Something different than it started with. We haven't looked at examples of that. Just,
Because I'm confused.
okay,
I have the book.
yes. That can talk to you privately then. All right, questions thus far?
Well, what you were just saying, I was just reading about in the textbook.
Oh, good.
So water is the most important agent of chemical weathering. Oxygen dissolved in water will oxidize some materials. For example, an iron nail is found in the soil, it will have a coating of rust. Iron oxide, and if the time of exposure has been long, the nail will be so weak that it can be broken as easily as a toothpick. And then it says carbon dioxide dissolved in water forms a carbonic acid. So I would say that that's probably
So it's never just water.
Never
It's water
just
with
water.
dissolved gases.
always got some dissolved.
Okay, all right, great. Thank you, Jennifer, for making that up. So did this graphic organizer help consolidate some thinking? Okay. So weathering is an external process critical in the rock cycle. So how would that impact the rock cycle if we didn't have weathering? If there were no weathering, how would that impact the rock cycle?
We'd have lots of lava.
If there were no weathering, that's a good point, there would be no,
There'll be nothing.
there would be no,
No
that
rock.
cycle would stop, there would be no sedimentary rocks.
Yeah.
And there would be no breakdown of rocks on the surface.
That's so out of luck.
So here's some examples of weathering. Has anybody been to Palo Duro? Is this what it looks like? Okay, can you describe it for us?
Palo Duro,
Palo Duro Canyon.
very dry, very windy, lots of llanos, probably llano estacado, plateaus, that's the real
Okay.
word. Where's it at?
Where's it at?
It's north of Lubbock and over by Amarillo.
Okay, alright.
Yeah.
What formed it?
Well, I mean,
How was it formed?
water and wind would be it's also been like 10 years, if not longer, so I'm trying to remember. But I can't remember what the rocks were made of.
Let me just, stop you just for a second.
Yes.
I'm hearing wind. Oh, y'all are saying wind. Wind
Is rock
does affect rocks, but
Tiny.
about this much, if y'all can see the very end of my pinky, it's very little. Water is 99.9% of, so we're not even gonna look at wind. The only time you're gonna really think about wind is when we're talking about desert areas. So here, what formed this canyon?
Water.
Okay, so was it just a rainstorm or?
No, hundreds of thousands, millions of years of activity.
Okay.
I'm trying to figure out what you're searching for, so I don't know.
So was it like just a lot of rain over that time, or did something form that led to?
Are you asking, like, is there a river system that formed the
Yes.
gorge?
Yes,
Okay, yeah. Why?
that's what I'm asking.
I thought I already said a river.
No.
Oh, yes. Moving water in the form of a river.
Moving water in the form of the river. So that river was there, and was it this deep to start with?
No.
So over time, what happened to that river system?
It weathered away, weather eroded and deposited the rock elsewhere.
Yes, so that river carved out that canyon, just like it did at Big Bend. Have y'all been to Big Bend? So these are 2 trips we can take. Big Bend is the same way. Yes, Elizabeth?
I have a question and I'm not sure how to word this, but if we're not referring to wind, because you mentioned that it was windy, is it more in reference to the particles of sand carried by the wind that would break down everything? Is that a more
What-
justifiable way of saying it? Instead of saying wind, because you said don't, because the wind's only a small part that would cause the breakdown, is it more justifiable to say the particles of sand that carried her in the wind that help break down faster?
You mean like sandblasting, that
Yes.
kind of thing? That can occur, but it doesn't
It's a
occur.
little longer.
Yeah, that's mechanical, but it doesn't, that's not a huge impact in Texas. So it's the water over time that weathered, then eroded, which carries it, and then took that sediment somewhere else, like the Gulf,
Only
and
because
deposited it.
when we were studying ecoregions, it mentions that when we're looking at the Pecos, if I'm not mistaken.
Pecos?
Yes, and it was talking about wind erosion with this, wind erosion and the weathering because of the sand constantly hitting.
Yeah, and wind does affect, but it's not equal to the water at all.
Okay, yes.
So, when you hear wind and water formed Palo Duro Canyon, well,
That's putting them
technically, but it was water and the wind was a little helper.
Gravitational pull.
Yeah. Okay, another one that maybe we need to field trip to is the Grand Canyon, but on our way to Vegas.
I've been there. Okay.
Do you see how quick she changed her mind?
Drive there in bed.
We did that.
Okay, let's see. So now we're gonna look at weathering. I mean, we've looked at weathering. Okay, so here's the weathering steps. Rocks are exposed. They're mechanically or chemically weathered. Gravity moves the debris down the slope, and that's called mass wasting. Just FYI, you may see that term, you will see it in your textbook when you read about this. Mass wasting is the transfer of rock and soil down the slope under the influence of gravity. So this gravity pulls things down, and it mechanically weathers it as it goes down. All right. We're going to look at erosion now, and how weathering and erosion shape your landscape. And so we are going to do a hands-on. On your handout are the directions. Here's my handout. So here is your stream table investigation in your handout. The purpose of this is to observe the effects of erosion on sediments. Okay, so this is complicated, so you need to look at what we're talking about up here. Your stream table. This is your stream table. It's official. You're going to elevate one end on a board. Have this end at the edge of your table. Y'all listen. Have this end at the edge of your table so that when you put your drain tube, and you'll have to straighten, can you straighten that out? You have your drain tube and you plug your drain tube into the end of your stream table. Then the water can drain into the tube that is resting on a chair or something below. When you place your sand in your stream table, place it up at the top here so that it will have somewhere to go. No. No. Bring those eyes, roll it back a little bit. You good? You okay? Okay, are there any questions? Okay, we need that big bucket of sand. Okay, the big bucket, the sand is over here. We'll have a scoop or something for you to get this out. I think the directions are in your handout. If you have any questions, you may ask. Wait a minute. We're all-